right, guys, this is part 2 of our day 9 video lessons. So we just practice finding what points were on the unit circle given various radian angle measures. Now let's talk a little bit more about definition of our trig functions and finding those values given different side lengths of triangles, right? Every time we're finding a point on the unit circle, essentially what we're doing is we can draw, that triangle, and those triangles help us to figure out where those points lie. Okay, so let me go ahead and just draw a triangle here. Okay. All right, so if I have this triangle here, remember it does have to be a right triangle for us to use these trig functions. Well, we know anything that the hypotenuse is always across from the 90-degree angle. And we know that, let's just say we're going to use this bottom left hand angle, 30 degrees is our angle point of reference. So for instance, a little recap of something that we've already done is, let's just say we have sine of the angle, so that 30 degrees. Sine is opposite, think SOHCAHTOA, opposite over hypotenuse. And so if we have a 30-degree angle measure, if you look on our unit circle at 30 degrees, the y value of that coordinate point is 1/2. The x value is √3/2. Okay, we also did that up top in the warm-up. And so sine would be opposite over hypotenuse. The hypotenuse is always 1 for the unit circle, so it would just be 1/2 divided by 1, which is just 1/2. Cosine then would be the x value, so √3/2. And then tangent, so I mentioned earlier that we also have tangent that we use quite a bit. And so tangent, as long as we know sine and cosine, we know what tangent will be then. Because tangent, if you look here at our rule, okay, our trig function, tangent is going to be y over x, meaning we're going to do sine over cosine. So for this example, I'd have tangent of the angle y, or sine, would be 1/2 on top over the over cosine over x. Now I would want to get rid of the square root in the denominator and simplify this. For time purposes right now, I'm not going to do that, but just wanted to show you how, knowing sine and cosine, I know tangent. So here are all the rules. We've already talked about how sine is y, how cosine is x, and so therefore tangent is y over x. In other words, sine over cosine. That's actually something we learned back in geometry, some of you might remember. And then, as we've talked about before, each trig function is related to another trig function that's just the opposite of it. So sine is related to cosecant, which is 1 over y. Secant is 1 over x. And cotangent would be tangent flipped around, so x over y. Okay, so notice those are just all flipped from the trig function next to them. Okay, and so all of these shortcuts work for points on the unit circle. Okay. So let's do an example. We're going to find the values of each of these trig functions given this point on the unit circle that corresponds to an arc length of t. Okay, so this point is really the most important thing that we are given. We know that the x value of this point represents cosine of the angle, and the y value is sine of the angle. Okay, and we know that that's true because that is a point on the unit circle. Okay, so I have cosine, we already know that guy, -1/2. And so that makes it really easy to actually then say what secant will be. Secant is just cosine flipped around, so -2/1, so -2. Sine is also something we can go ahead and state. It is that y value of the coordinate point. And so cosecant, remember I told you guys every C needs an S, so sine, that's an S, it needs a C, so it gets cosecant. If we flip that around, so that's 2/√3. We do not like that square root in the denominator, so I'm going to go ahead and get rid of that by multiplying by √3 on top and bottom. So on the top, just multiply straight across on top and bottom. 2 times √3, can't simplify that at all. √3 times √3 will just be 3 then. Okay, so there's our answer for cosecant. And then lastly, tangent. Okay, remember that is sine over cosine, or in other words, y over x. So I'm going to put √3/2 on top, -1/2 on bottom. And now I don't want a fraction in my denominator, so I don't want fractions within fractions. And so something we can do is to get rid of that with -1/2 in the denominator is, instead of dividing by a fraction, multiply by the reciprocal. So instead of writing 1/2, I'm going to write 2/1. Okay, and so across top, that would be -2 times √3 over, multiply across the bottom, and we get 2. This 2/2 will cancel out, so that leaves us with -√3. Okay, and then for cotangent, I just want to flip that around. So that -√3 is technically over 1. So when I flip that around for cotangent, I'm going to get still negative, but 1/√3. Don't want that square root symbol in the denominator, so to get rid of it, multiply by √3 on top and bottom. And so across the top, I have -1 times √3, and then √3 times √3 is just +3. Okay, so there's an example of how we can find all of our trig functions only given one point on the unit circle. All right. So referring back to our right triangle trig, so we're going to use those same rules now given triangles to find well, I guess actually I'm not going to go ahead and find each one of these, just going to mention it real quick. So just for time purposes. So we know, right, that let's for instance say sine, okay? We know SOHCAHTOA, so sine is opposite over hypotenuse as we see here. Cosine is the ka, tan is the toa, and so for the other three trig functions, we would just flip those around, okay? So cosecant would be the hypotenuse over opposite. Secant is hypotenuse over adjacent, etc. So for instance, looking at this left-hand triangle, if I wanted to find, let me say cosecant. Well, cosecant is sine flipped around, so hypotenuse over the opposite. Well, the hypotenuse here of this triangle is 1. The opposite of this angle is root 2 over 2. And so then we would just want to go ahead and simplify this. So instead of, again, dividing by a fraction, I'm going to multiply by the reciprocal, and that would leave me with 2 over root 2. To get rid of that root 2 in the denominator, multiply by root 2 on top and bottom. So I'll get 2 root 2 over 2. Those 2's cancel out, and I just am left with root 2. All right, and guys, just a little thing to note. If you're doing this simplifying like I was doing and you're not sure if the answer, the radical you got, is equivalent to what you started with, you can just compare what you started with before you got rid of the square root to your final answer. So in other words, you could take your calculator, do 1 divided by square root of 2 divided by 2, and then in your calculator also do square root of 2 just by itself, and notice that they both equal the decimal about 1.41. So you know you did it right. Okay, now let's just say I'm looking at the second triangle and I'm going to find secant of this angle theta here. Well, secant is going to be hypotenuse over adjacent, opposite of cosine. So the hypotenuse here is 5 root 2, and the adjacent side would be to this angle 5. And then those 5 would cancel out, and it would equal root 2. Okay, so just a couple examples of how to find them from given triangles. All right, so let's go ahead and find the 6 trig functions of each given angle. And so I am gonna show you what these are in degrees as well, but we do want to get to the point where we are comfortable with radians and we're not always trying to convert radians to degrees every single time. Okay. Where's my pen? There we go. Okay, so pi over 6, if I were to convert that by multiplying by 180 over pi, I would get that this is also equivalent to 30 degrees. So pi over 6 or 30 degrees is how we can think of our angle measure. So first, I'll write this over here. First, find the terminal point, so where we stop at, then proceed like before. Okay. All right, so pi over 6, if you are looking at your unit circle, you will see that pi over 6 is going to lie, draw that. About right there on your unit circle. And so on the unit circle, if you notice, that has the point root 3 over 2, comma 1/2. Okay, we also did that on the warm-up. All right, so now we're going to find the 6 trig functions. So if we have, let's start with sine. So sine of pi over 6, we know that's going to be the y value of this coordinate point. So 1/2. That makes it really easy to find cosecant. I'm just going to flip around that 1/2, so 2 over 1 is 2. Now I'm going to find cosine. Well, that's just going to be the x value of that coordinate, so root 3 over 2. So that makes it really simple to find secant then. Just going to flip that around. So that is 2 over root 3. Need to get rid of that square root symbol in the denominator. And so I get 2 root 3 over 3. Okay, and then lastly, I want to find a tangent and cotangent. I'm going to do that up here just for, I don't want to run out of room. So tangent of pi over 6, well, we know tangent is sine over cosine, or in other words, y over x. Okay, so I have y over x. Now, just like before, instead of dividing by a fraction, I'm going to multiply 1/2 by the reciprocal of that fraction. And these 2's will cancel out. And that leaves me with, for tangent, that 1 on top, root 3 on bottom. I want to get rid of that square root symbol. And so I have 1 times root 3 on top is root 3, and then root 3 times root 3 is 3. Okay, so there's tangent of my angle. And then so cotangent would just be this flipped around. Okay, and so that's, I'm gonna just do it before I got rid of the square root for tangent. That way I don't have to do the same thing for cotangent. So before I got rid of the square root, I had 1 over root 3. So that's what I'm going to use. I'm going to flip that around, root 3 over 1. So just root 3. And notice I didn't have to simplify since I used my tangent value before rationalizing. Okay. So part B, we have 3 pi over 2. And so I'm not going to find sine, cosecant, cosine, and secant since we've been doing those. I'm just going to go ahead and find tangent and cotangent for time purposes. So if we're looking at our unit circle, I wrote in all of my room here. Okay, so I'm doing part B. So 3 pi over 2 on the unit circle, that would actually be my axis down here. So I'm looking for that terminal point, and that's going to be 0, -1. So in other words, cosine of this angle, 0, sine of the angle is -1. Okay. You know what, whatever. I'll just go ahead and write them real fast for everybody. So sine of 3 pi over 2 is the -1. Cosine of 3 pi over 2 is at 0. So then we are going to find cosecant, that's related to sine. Well, -1 over 1, if we flip that around, that would be 1 over -1, which is just still -1. And then if I find secant, okay, that's going to be cosine flipped around. Well, this 0 is, as any number, is technically over 1. So if I flip that around, I get 1 over 0, but wait, remember, we can never divide by 0. So that means that secant of this angle is undefined. All right, go ahead and make sure you have these written down because I am going to erase So I have room to write tangent and cotangent. Okay, now I'm gonna find, actually I'll leave that there. All right, so now tangent is going to be sine over cosine, so -1/0. So again, as we just saw with secant, that is undefined. We cannot divide by 0. Oops, cotangent though of 3π/2, that's going to be this flipped around. So 0/-1 is just 0 for cotangent. So we can do 0 divided by something else. We cannot do something divided by 0. If you try to do -1/0 in your calculator, you would get an error. Okay, so we're going to go ahead and find the exact values of A, B, and C. Notice now we're going to introduce maybe adding and subtracting these values, okay? So sine of 2π/3, we have already been practicing finding values like that. So looking at your unit circle, or maybe if you've memorized it, oopsies, we have 2π/3, that terminal point there. Is going to be -1/2 √3/2. And so sine of (2π/3) is that y value, √3/2. Okay, now let's go ahead and do, I'm going to do actually part C first. So tangent, actually, no, it's fine. I'll do part B first. So cosine of 21π/4 plus sine of π/2. So we want to find the exact values, okay? When you see exact value, okay, you want to give me a number, not the radian measures, not a degree measure. I don't want to see the trig function, tangent or cotangent written. I just want a number, okay? Just like we did in A, I got the number √3/2. Okay, so first I want to find, I know 21π/4 is not in between 0 and 2π. It is much larger. So I'm going to find an angle that is coterminal to 21π/4. So I'm going to do that by subtracting 2π over and over again until I get something between 0 and 2π. So if I subtract 2π, I do want a common denominator 4, so instead of writing 2π, I'm going to write 8π/4. 8 divided by 4 is 2, so that's equivalent to 2π. Well, I know that 21 minus 8, that's going to give me 13π/4. That's still over 2π, so I'm going to subtract one more 8π/4, and that gets me 5π/4. Okay, and so what I'm basically now finding, instead of cosine 21π/4, I'm finding cosine 5π/4 plus sine π/2. Well, if you look on your unit circle, cosine of 5π/4 is going to be -√2/2. Sine of π/2, look at that point, and we see that the y value is 1. And when I add these two together, I need a common denominator. So I'm going to make 1 be 2/2. And so when I simplify this, you can either write -√2 plus 2, or you can write 2 minus √2. Either way, it is the same thing. So I just flipped it around. I just did 2 minus √2. All right, part C, so now tangent of 45 minus cosine of 30. So first we need to find what tangent of 45 will be. Okay, well, I know that on my unit circle, 45 degrees is here. I know that both x and y are root 2 over 2. Okay, and we know that tangent is, so tangent of the angle is going to be y over x, or in other words, sine over cosine. Well, notice I'm just dividing root 2 over 2 by itself. So this is equivalent to 1. Okay, so for tangent 45, I have that that's equal to 1 minus cosine of 30. If you look at the x value on your unit circle for cosine at 30 degrees, you're going to get root 3 over 2. All right, and now we can subtract. We need a common denominator, so I'm going to change this 1 to be 2 over 2. And so this gives me 2 minus root 3 over 2. And that's the exact value for that. All right. Okay, so for secant, cosecant, and cotangent, we know we use the opposite, so the reciprocal functions. So cosecant, we already mentioned earlier, right, how that's opposite of sine. So notice it was just sine flipped around. So instead of y over 1, it's 1 over y. Well, it's same thing with the trig function itself. So cosecant would be 1 over sine. Secant is 1 over cosine, cotangent is 1 over tangent. So just another way to rewrite these values here, right? We know y is sine, so if you replace the y with the sine, you would get 1 over sine for cosecant, or 1 over cosine for secant, etc. Okay, so we're gonna actually use the calculator to approximate these values. And that, guys, this is just kind of a little recap. Okay, we've been working with that though, up to this point. Okay, so we're going to use our calculators to estimate these. All right, and actually I need to, sorry, my bad, run and go grab those. Okay. And guys, actually, just for time-wise, because running kind of long, oh no, it's fine. I'm just gonna do this really fast though. Okay, so if I have, first off, a cosine 48, make sure in mode you're set to degree mode, and you'll get an approximated decimal, 0.669. Okay, if we did cosecant of 21 degrees, well, that means, again, make sure you're in your degree mode. And then for cosecant, I'm going to do 1 divided by, right, we're going to use the trig function. I'm going to do 1 divided by sine of that angle. And when I do that, and I get approximated decimal, I get it's about 2.79. All right, and then lastly, that is tangent. That is in radians though, so I need to change my mode on my calculator to radian. And then I know tangent is going to be, we have that on our calculator, so tangent, and then I'm gonna type in pi, so you can do second, and then that is the, pi is right above the up sign, up symbol under the clear button. And so I'm going to do pi divided by 12, and we're going to get an estimated decimal of 0.2. 6/8. Okay. So sometimes there are right angle measures that we don't actually know on the unit circle, like the 48 degrees or 21 degrees. And in those cases, we will need our graphing calculators. All right, guys, almost there. Last page of the notes. So I actually already did talk about this. So signs of the trig functions, that would be related to our quadrants, right? So we have quadrant 1, 2, 3, 4. I already talked about why sine and cosine are positive. So if this doesn't seem familiar to you, maybe you zoned out earlier, I would go back. That would have been here on page 1. I talked about it. So I'll go back to there if this is not something you're recalling from earlier. Okay, so we have more trig functions than just sine and cosine, right? So we talked about how in quadrant 1, both sine and cosine are positive. That means that tangent must also be positive, right? Sine over cosine equals tangent. So if sine over cosine are both positive, tangent must be positive, which then means that all of their related trig functions, secant, cosecant, cotangent, are also all positive. So all trig functions are positive here. That's because no matter what, any point on this circle, to get to it, we're going to have to go in the positive x direction and the positive y direction. Okay, quadrant 2. I told you guys that cosine was negative. Sine is positive, and so tangent, if we have sine over cosine, a negative or a positive divided by a negative, that's going to make tangent negative. For quadrant 3, I told you guys that both cosine and sine were negative. Well, for tangent, a negative divided by a negative would make them this positive. And lastly, quadrant 4, cosine is positive, sine is negative, and so tangent, negative divided by a positive is a negative. Okay. All right, so let's do an example. Determine the sign of the trig functions. And so part A, well, 2 pi over 3, that is in quadrant 2. Be right there, about. And so for the sign, sine in quadrant 2 we see is positive. All right, part B, tangent of 315 degrees. Well, 315 degrees would be in quadrant 4. Okay, so it would be 270 is 270 is this right here. This would be 360. So 315 would lie somewhere in this 4th quadrant. All right, and so in that quadrant, we see tangent is negative. All right, now next example. So from this information given, let's determine the quadrant in which the terminal point lies. All right, so I'm gonna draw little pictures. So if I have my, all my quadrants drawn. All right, so sine, I'm gonna do that in the blue. Cosine, I'll do that in the red. All right, so sine is negative. All right, well, if sine is negative, then that means it either has to lie in the 3rd or the 4th quadrant, because in the top 2, sine is positive. Now, if cosine, it also says is positive. Well, if cosine's positive, then that either has to lie in the 1st quadrant or in this 4th quadrant. And so notice that I have overlap of my colors right here in the 4th quadrant. So this would be the quadrant where both of those conditions are satisfied. So quadrant 4 is my answer. All right, part B, cosecant is negative. So what that tells us is that sine is also negative. since those are related to each other. So sine, again, is only negative, where we have the third and the fourth quadrants. And then it says tangent is also negative. Well, tangent, if it's negative, will either have to be in the second or fourth quadrant. So once again, we see that there's overlap right here in quadrant 4. Okay, and that's super important especially when we're finding the exact values, and where we need to use information like this to figure out, are we positive or negative though for that value? All right, so a point on the terminal side of an angle is given. Find the exact value of the 6 trig functions. So these are different because notice that these are not values on the unit circle. So the point -2, 3, you won't see that anywhere as a point on your unit circle, nor 5, -12. And so in this case, this is super, super important because these do not lie on the unit circle. Cosine cannot equal x, and sine does not simply equal y. Okay, so we're going to have to use another strategy to figure out where are these going to, or what are these going to be. Okay, so if you do not have a point on your unit circle, the first thing that you should do is draw a triangle. All right, so looking at my point, I see that I have 5, +5. That means I went +5 in the x direction. -12 means I went down 12 in the y direction. Okay, and notice if I connect from my center to my point here, I have a triangle, and a right triangle at that. Okay. Also, guys, if you're not sure which way to draw your triangle, a little helpful thing, triangles should always satisfy this bow tie shape that I just drew. So notice in the 4th quadrant, my triangle matches what that bow tie shape looks like. All right, so now we need to find all of the trig functions, but before we can do that, we need to find our missing side length here, the hypotenuse, okay? Because again, we're not on the unit circle, so it's not necessarily just one. So I'm going to use the Pythagorean theorem. So we have 5 squared plus -12 squared equals, actually I'm going to call it h squared. Or I'll just do c squared since we're used to that for Pythagorean theorem. All right, well 5 squared is 25. 12 squared, -12 squared is +144. Well, 25 plus 144 is 169. And take the square root of that, and I get c is equal to 13. All right. And the hypotenuse, that's always going to be positive. Okay. So now finding all my trig functions. Let's do the space over here. I have first, I'll just do cosine. So cosine of the angle, and so the angle, guys, always lies in the corner at the origin, always. And so cosine of that angle, well, we know cosine is adjacent over hypotenuse. So adjacent to that angle is 5, and the hypotenuse is 13. All right, and so that means secant then is just cosine flipped around, so 13 over 5. All right, now let's do sine. Sine of the angle we know is opposite over hypotenuse, and so that's going to be -12 over 13. So now we can easily find cosecant. That's going to be hypotenuse over opposite. or in other words, sine just flipped around. Okay, and then we have tangent of the angle. That's going to be opposite over adjacent. So that is -12 over 5, which means that cotangent of the angle is going to be 5 over -12. All right, guys, I'm not going to do the next example. I ran out of room. It is on your filled out notes, but the same thing here. You would just want to draw your triangle. So -2, -3 would means backwards 2 in the x direction, down 3 in the y direction, and then here you would have your triangle in the third quadrant with that angle measure and the origin as always. All right, guys, so use Pythagorean theorem, find that hypotenuse, and then do what we did to find all the trig functions. That will conclude today. You guys have a great